Hello, I welcome you to today's lecture of Overview of Communication Systems. That is our lecture notes 2, and my name is Echan Osei Donko. At the end of this lecture, you will be able to describe what a system is and list the types of systems. You will also be able to describe the elements of a communication system, develop a block diagram showing the elements of the communication systems, and finally, you will be able to explain the modes of communication transmission. Let's go. A system. So what is a system? What comes into mind when you think about the word system? The education system, maybe the political system, the religious system, or maybe just an audio system. No matter which one comes to mind, there is one thing that is certain, that in all these systems, there is an input that is turned into a product at the output. And the kind of product that is made helps you to understand the processes that goes on in the system. So in other words, in its basic terms, a system should have certain processes that it does on an input in order to produce a certain output. A system must have at least an input and also at least an output. The physical system, for example, if we take a resistor, whenever there is current flow in a resistor, it is going to drop a certain amount of voltage according to its resistance. So the resistor is a system. So the physical resistor here can be considered a system, especially when it is within a circuit. And the process that is going on within the resistor in order to produce that kind of output, the mathematical model is also known as a system. So whether it is a physical or a mathematical one, they are both systems. And we define the system as a mathematical model of a physical process that relates the input signal to the output signal. And we signify the system with the letter T, as shown in figure 1. When the processes T occur on the input X, they produce the output Y. And so the system is a well-defined rule by which X, which is the input, is transformed into Y. We have 3 basic types of systems: the single input, single output system, multiple inputs, single output system, multiple inputs, multiple output system, and we can also have single input, multiple output systems. An example of that one is the demultiplexer, which takes single stream of signals which have various center frequencies and then outputs them at multiple outputs with their different center frequencies. Single input, single output means that it has just one input and then the output is also one. One input, one output. An example of the single input, single output is a resistor or a capacitor. Then multiple input, single output system is a system with multiple ports at the input and just a single output. An example is the multiplexer. Then multiple inputs, multiple output systems. They have multiple inputs to them and then multiple outputs also to them. An example is the full adder. So now we come to the communication system. A communication system is a system that conveys information from its source to a destination some distance away. Now we should also understand that a system can have other subsystems within it working together to get its final output. The communication system is a system with many subsystems. The 3 essential parts of any communication system are the transmitter, the transmission channel, and then the receiver. So the transmitter is the one that picks the input, the source of the information. The transmitter outputs the signal through a channel. The channel can either be the air or a cable, like a coaxial cable or an optical fiber cable. And then it gets to a receiver. The receiver picks up the signal. The signal is then converted back to information that can be utilized by the user. Information is the source of a communication system. It is what the communication system is seeking to transport from one end to another over that distance. So we need the information for the communication system to thrive. When that information is converted to an acceptable form that is usable by the communication system, we call that the message signal. So the message is the physical manifestation of the information, right, as produced by the source. And the goal of any communication system is to reproduce an acceptable and useful form of the source message at the receiver's end. The source of information is mostly analog, and therefore most of the time the message that is produced from the source is analog. Analog signal is a signal that varies continuously with time. It means that there is no break in the signal at any point. Examples of that are the acoustic pressure produced during speech. And if you take a look at a speech signal, it is continuous. There is no break in that signal. However, an analog signal can be converted into a digital form, and that digital form becomes the source message for a certain communication system. We have sources of information that are inherently digital. Digital means that their amplitudes are from a discrete set of elements. Not only are they defined for certain discrete points in time, their amplitudes are also defined for certain discrete values. It has to conform to a certain preset voltage values. An example of digital signals that are actually message sources or sources of information that can be transmitted include the signal from a computer keyboard. So the information from the source can be converted to electrical signals using transducers, and can also be converted from the electrical form to a form that can be appreciated by the users, also using transducers. So we have input transducers and output transducers. Whereas the input transducers convert energy in other forms to electrical form, the output transducers convert energy from electrical form into other forms. So a transducer is just a device that converts energy from one form to another. Figure 3 shows the communication system and where the input and output transducers will be situated within it. So we have the source of information, audible source of information. Then a microphone can be used to convert that into an electrical form that becomes the input signal to the communication system. And when the communication system has performed its duties on this signal, that signal becomes an output electrical signal. And that output signal is then passed through a loudspeaker, which is an output transducer, to produce the sound that we can appreciate with our ears. The transmitter is the part of the communication system where the input signal is processed for the signal to be suitable enough to be transmitted onto a certain channel, right? So the processing of the input signal occurs in the transmitter. The transmitter may be a separate piece of equipment or an electrical circuit within an electronic device. And the signal processing that usually occurs in the transmission include modulation and coding. We'll be talking a lot about modulation and a bit about coding in the course of the semester. The receiver, on the other hand, operates on the output signal from the communication channel. The receiver picks up the signal that is transmitted over the communication channel and prepares the signal for delivery. It sends that signal to a transducer, and then the transducer carries on converting that signal to a form that can be more appreciated by users, in a form that is very much like the original source information. At the receiving end, some operations that occur include amplification. Signals are demodulated and then decoded. There is also filtering that goes on at the receiver's end. Sometimes in between the main transmitter and the receiver, there are some systems that process the received signal and then retransmits. And such a system is called a transceiver, and they are usually located between the main transmitter and the target receiver. The transmission channel is the electrical medium between the source and the destination. This can be either guided, which means that the signal is sent within a medium that has boundaries, like cable. Examples of that can be the coaxial cable, the twisted pair optical fiber cable, or unguided, meaning the signal is thrown in the air via antennas using radio waves or microwaves for transmission. There is an amount of transmission loss or attenuation to any channel transmission. Attenuation occurs naturally as signals progress over a certain distance, because the amount of signal strength that is transmitted over a certain distance will certainly wane off, and that is the cause of the attenuation. There are other factors that affect the integrity of the channel's transmission. They include interference, noise, and distortion. Interference usually occurs from extraneous signals from other transmitters, power lines, machinery, switching circuits, etc. Most of the time, receiving antennas intercept several signals at the same time, and when it happens, these signals can cause interference in the original signal that the receiver has been tuned to. And in cable systems, interference can occur if the transmission wires or the receiver circuitry picks up signals radiated from nearby sources. The appropriate filtering techniques, when employed, are able to remove interference to a large extent. Noise is the random, unpredictable electrical signals that corrupt the received signal. The noise can be produced by the processes occurring within the transmission system, within the receiver system, and even within the transducers. Thermal noise that occurs as a result of the components within the circuitry is one type of internal noise. There are also sources from outside the system that can also affect the integrity of the signal. Filtering can also reduce noise contamination to a very large extent. Distortion, unlike noise and interference, is a wave perturbation that is caused by imperfect response of the system to the desired signal itself. When the system does not respond to the input signal very favorably, distortion occurs. It's easy for the distortion to disappear when that signal is turned off. In a channel with a linear response, distortion can be corrected or reduced by using equalizers. The equalizer is simply a system that is able to isolate certain frequencies and either increase or decrease them. So using such equalizing systems, distortion can be corrected completely or even very much reduced. The communication system is designed to be able to reproduce a replica of the information at the receiver, and so the system is expected to utilize two primary communication resources efficiently. We have the transmitted power, which is the average power of the transmitted signal, and the transmission channel bandwidth. The concept of the bandwidth applies as a measure of speed of the signals transmitted within the channel. And every communication system has a finite bandwidth that limits the rate of signal variation within it. And for a digital system with R symbols per second, the bandwidth is given as equation 1, that is B is greater than or equal to R over 2. Channel capacity is a way of estimating the maximum limit on a channel's performance based on the channel's bandwidth and its signal to noise power ratio. So we have channel capacity given by the Shannon-Hadley law in equation 2, where C, which represents the capacity, is given as B is bandwidth log 2 of 1 plus the signal to noise power ratio. Now the signal to noise power ratio should be resolved not in decibels, but in its original ratios. There is a sample question here that says, find the maximum channel capacity for a channel with signal to noise power ratio of 20 decibels and 1000 kilohertz available bandwidth. So first we write out our data. We have signal to noise ratio being 20 decibels and bandwidth is 1000 kilohertz. So 1000 times 10 to the power 3 hertz. Okay, and we need to convert the signal to noise ratio from decibels to the original ratio. We know that decibel is equal to 10 log 10 of whatever value. So let's say x. So the decibel form of x is equal to 10 log 10 of the actual value x. And so to be able to find this actual value, the decibel form of x is divided by 10, and then we find the antilog of that value, which is x decibel over 10, and antilog is the same as 10 to the power. So in other words, 10 to the power x in decibels over 10, and that will give us x not in decibel. So the signal to noise power ratio of 20 decibel will become 10 to the power 20 divided by 10, giving us 10 to the power 2, and that is equal to 100. So then we have C is equal to 1000 times 10 to the power 3 log 2 of 1 plus 100. Log 2 of 101 is 6.658. So 6.658 times 1000 times 10 to the power 3 will give us 6.658 times 10 to the power 6 bits per second. So 6.658 megabits per second. Channel capacity is not measured in hertz, it's measured in bits per second. Communication transmission can be categorized into three main modes. We have the simplex transmission mode, half duplex transmission mode, and the full duplex transmission mode. In the simplex transmission mode, communication occurs only in one direction. We call that the unidirectional communication, where the transmitter sends a message but cannot receive any message from the receiver. So it uses only one channel for such a communication. And an example is the conventional television broadcast, or even FM radio broadcast. The computer keyboard and the computer monitor are also examples of simplex transmission. Duplex communication transmission. And duplex here meaning when the transmitter sends information, the receiver after receiving is also able to transmit information back to the transmitter. However, we have two types of the duplex transmission mode. We have the full duplex and the half duplex. In the half duplex, communication still uses only one channel, though it is a two-directional communication. And so the transmission cannot be simultaneous, meaning that the receiver cannot send an information to the transmitter whilst the transmitter is also sending an information to the receiver at the same time. They need to make use of just one channel, and communication occurs one after the other. An example of such a communication transmission mode is the walkie-talkie. We see it used mostly in police circles, where a policeman sends information to his partner, then he has to wait and listen to his partner, who is now able to turn on the transmission mode and then transmit to him. So the communication between them cannot occur at the same time. Then the final one is the full duplex. In the full duplex transmission mode, communication occurs simultaneously because there are two channels in use, one for the transmitter to send to the receiver and one for the receiver to send to the transmitter. So when any of them is sending information, they are using channels that have been dedicated for their transmission, which means that the transmitter has a channel dedicated for sending information to the receiver, and the receiver has a channel dedicated for sending information to the transmitter. All right, so that wraps it up for our overview of communication systems. I hope you learned something. I hope to meet with you again another time. Have a nice day.